So where does the sine rule come from? Let's derive it. Let's draw up a triangle. We'll call it triangle A, B, C. I've labelled the vertices of these triangles with capital letters because that's pretty common. The vertices are the angles or corners, some people call them. And what's also common is if you have a capital letter vertex there, the side opposite to it is labelled little a, the side opposite B is little b, and the side opposite capital C vertex is little c. So sometimes people call that side capital A, capital B. Sometimes they just call it side C. Just write what I mean here. Side AB is the same as side little c. That's what we're talking about there. So I've got my triangle drawn up and I'm going to derive the sine rule from that. So I pick a vertex, an angle, say angle A, and I drop a perpendicular to the side opposite angle A. I draw a line so that it's at right angles to the side that's opposite angle A. By doing that, I've created two triangles that I can work with. And my new side length, I will call H. That height there is H. So let's peel off those two triangles. First of all, this triangle here, it's made up, there's vertex A on it, there's side B, there's vertex C, and there's the letter H there. So I've pulled that triangle off there, and let's pull that triangle off. That's little c, that's B, A was up the top, and that's side H there. Be careful because angle A is actually all that angle, and now I've split that up. But just so you could see where those triangles came from, I've labelled it that way. Let's first of all look at the blue triangle. What is sine of C? Sine of C is equal to opposite on hypotenuse in the triangle with that C in it. Opposite on hypotenuse. That's H on B. Rearranging that, I can say that H equals B times sine C. There's a little times in there. So that's the value of H described out of the blue triangle. Now that's the same H there and there. Let's have a look over here at sine of angle B. Sine B is opposite on hypotenuse in that triangle. Opposite is H, hypotenuse is C. So it's H on little c. So rearranging, H equals C sine of B. Now, H is equal to H. So I can say that this B sine of C is equal to the C sine of B, and they're both equal to H. But it's this bit that I'm interested in. B sine C equals C sine B. If I divide both sides by sine B, I get B sine C divided by sine B equals C. If I divided that by sine B, it gets rid of the sine B and it just leaves me with C. Now I'm going to divide both sides by sine C. B over sine B equals C over sine C. And I've got already part of my sine rule. Now I'm going to take that same triangle, triangle ABC, ABC, labelled A, B, C with the little letters for the sides opposite to it. But this time I'm going to drop a different perpendicular. Now, maybe I can drop that one there at right angles to the side opposite to it. And now I'm going to call this side, instead of H, I'll choose another letter. I'll call it D. It's the length there. Once again, I've created two triangles. One, 2. And I'm going to peel off those 2 triangles. Let's peel off this triangle. It looks like it's got, there's A, there's C. But remember, C's been cut in half here, so you've got to be careful. That's not really the same size, just for labelling purposes. That's D there, and this is little b. So that's the triangle number 1, and let's peel off triangle number 2. That's angle B down there. That's part of angle C, so for labelling purposes, that's A and that's D. Once again, I'm going to find sine of angle A in this one. This angle came completely through. I wouldn't want to find sine of angle C because it's been split up. It's just there for labelling purposes. But sine of angle A is opposite on hypotenuse, D on B. How did I know that was the hypotenuse? Because it's opposite the right angle, which is the longest side is always opposite the right angle. Rearranging, D is equal to B sine A. I'm going to do the same thing over here. I'm going to work out sine of B, opposite on hypotenuse, D on A. Rearranging, D equals A sine B. Now, because they're both equal to D, I'm saying that B sine A is equal to D, but also A sine B is equal to D. But what I'm interested in again is just those two. I'm going to divide both sides by sine B. So B sine A on sine B equals just A, because I divided that by sine B. It's now just A. Now I'm going to divide by sine A. So B on sine B, I divided away the sine A that was there, equals A on sine A. And that's another part of the sine rule. So putting together what I've just found, I'll just move this up here, what I've just found in the box and what I found in the box on the previous page, I've just folded it over, but I found that. I can see that, sorry, let's fold that a little bit better. I can see that B over sine B equals A over sine A, and B over sine B equals C over sine C. So A over sine A is equal to C over sine C because it equals B over sine B. A over sine A equals B over sine B, and B over sine B equals C over sine C. So all 3 of these are equal to each other. And that is known as the sine rule. And the sine rule is saying that in the one triangle, a side and the sine of the angle opposite to it equals a different side and the side of the angle opposite to it, sine of the angle opposite to it, or a different side and the sine of the angle opposite to it. And we normally take them in pairs. So we might work with that pair, or we might work with that pair, or we might work with that pair. But we normally take a pair to work with. And that is where the sine rule comes from.